Hello, everybody. All right, so this lesson is going to cover the topic of drawing angles in standard position. All right, we are also going to, while doing that, talk about how to convert between degrees and radians. And we are going to end this video with a topic on arc length, all right, which kind of ties everything together. All right, so at this point you should be in your notes packet, and we are going to start right here at the top of the second page on drawing angles in standard position. All right, so the first thing you need to know is that any angle that you draw is going to have three parts. The first part is its initial side, all right, which is a ray that will always, this initial side, is a ray that will always start at the origin and it will go out horizontally. It will always be horizontal, all right? So right out along the x-axis. All right, the second thing it is always going to have is something called a terminal side, and that's the place where it ends, all right? So this is the end, and it could be in any quadrant or on an axis, okay? So it also starts at the origin and goes out, all right, making my angle. This third part, this is key because the way we're going to talk about angles from now on is a little bit different than how you talked about them before. The third thing you need to do is you need to include a direction, okay? So that's some kind of an arrow to indicate positive or negative, all right? What that means is, in this first example that I've been working with, this arrow that I'm drawing over is going up from the x-axis. So this is representing a positive angle. Maybe that's representing a 30-degree angle, okay? Actually, based on where that's drawn, probably more like a 45-degree angle. But anyway, in the picture to the right, like the far right, we still have our initial ray right here on the x-axis. We still have a terminal side down here in the fourth quadrant, but as you can see, it has gone down. From the x-axis, it has traveled downwards. That makes this a negative angle, and so that would be maybe represented by a negative 45-degree angle, okay? So this place where x is, this is generally considered the spot where 0 degrees would happen, all right? And then, so 0 degrees, here, let me, 0 degrees. And if we're rotating positively, okay, if we're rotating positively, this spot at the top would be 90 degrees, because that's one quadrant, 180 degrees, 270 degrees, that's a 7. And then 0 could also be 360. Okay, hold on, that does not look very good. There you go. So those are some options, those are not options, those are the measurements of those 4 key places. So if we're going negatively, down here at the bottom would be negative 90 degrees. That means you've only gone negative 90 degrees in your turn around this circle. This would be negative 180 over here at the end, and then negative 270 degrees up at the top. All right, okay, so that's just a general benchmark for where all those values are. Now we're actually going to draw an angle. Hold on. Okay, sorry, just checking to make sure we were still recording. All right, so moving along. Thanks for the technical check. Okay, so we're going to do A and B, and then I'm going to let you try some of these other examples. Okay, so when we draw our angle, so we're going to draw our angle first. You start at the origin, you draw a horizontal initial side. Then you have to approximate where you think 220 degrees would be. So if this spot over here is 180 degrees and this bottom ray is pointing 270, it's going to land somewhere in between in this third quadrant. Okay, so I'm just going to kind of approximate that. And then I'm going to draw an arrow that says I went from here, this initial ray, around to this terminal side. Okay, and then let's just try drawing this negative angle. So same starting point, start at the origin, draw our initial ray going out. Negative 36. So if this ray pointing down is at negative 90 degrees, this is definitely going to stay in the fourth quadrant at negative 36 degrees, and it's going to have an arrow showing that it went down to get to that point. Now, aside from saying to draw, it also says if in degrees, convert to radians. Well, right now we have 220 degrees and we have negative 36 degrees. The conversion from degrees to radians is to multiply by pi over 180 degrees, and that's exactly what we're going to do. So this is like 220 over 1, so pi over 180, okay? So what I'm going to think about is that really this is like 22 pi over 18, because the zeros just go. And so 22 divided by 18 would be 11 pi over 9, because those are both divisible by 2, okay? So 11 pi over 9, that would be the radian value for the angle we just graphed, okay? We just sketched. And then let's do that with negative 36. So we're going to multiply by pi over 180 degrees, all right? Same deal. I'm going to think, okay, negative 36 pi over 180. I can tell you that 36 and 180 are both divisible by 9. So let's at least go from there. So negative 4 pi over 20, right? Because 180 divided by 9 is 20. So I think our actual answer would be negative pi over 5, because the top and bottom are both divisible by 4. So that's our radians for this second one. Okay, so I would like you to try C and D and then unpause this video and check. So pause the video, try C and D, unpause, and check your answer. All right, folks, so check your graph and see if your sketch and see if your angle matches mine, particularly the quadrant and the arrow. And then I got 13 pi over 18 for C, which is pretty straightforward. For letter D, I had to do a little bit more work, but I did get to 23 pi over 15. So hopefully the work off to the side helps with the 23 pi over 15 as the radians for letter D, because we want to try and do all of these without a calculator. Okay, so moving along. Same thing here. If you feel you need a little bit more practice, you can pause and try these problems. Otherwise, you can skip ahead a little bit onto the next part. I'm going to pause right now so that I can draw all these angles in here. So in just a moment, they should all pop right up on your screen. All right, folks, so if you want to check your answers to these 6 problems, here they are. Otherwise, as I said, we are moving on to the bottom half of that page, which involves all of these angles, which should look different to you because they are all written in radians. All right? Okay, so we need to talk about a couple of things. The first thing is just very simply that the 0 degrees, whether it's in radians or degrees, 0 is 0. So we always start over here on the right with a 0, whether it's 0 radians or degrees. Now, this spot up at the top was originally 90 degrees. If we convert that to radians, we would notice that 90 divided by 180 is a half. So that makes this value up here pi over 2. All right, and then actually this conversion factor that we're using says that pi is 180 degrees. So that means we know that the far left would have to be pi, because we're just taking out, we're substituting pi for 180. And then let's just round this out. So 270 degrees times pi over 180, that'd be 27 over 18, which would reduce to 3 pi over 2. So this value at the bottom is 3 pi over 2. Now, keep in mind, you may also need to kind of reference the fact that pi is approximately 3.14, and we'll get to that in a second. All right, so this angle here, pi over 5, so that's a fifth of pi. A fifth is less than 1/2. So this pi over 2 has to be bigger than pi over 5. So this angle that we're drawing should be somewhere in this quadrant. I'm just going to draw right about there. Okay, because it's probably going to be even less than halfway through. So we're going to draw our arrow still. And then let's do number 9 also. So pi over 12. Well, this would be, if we're going negatively, this would be negative pi over 2 down here, and 0 still there. So we're going to draw our initial side, and then a 12th. Probably going to be something really kind of tiny. So it's going to be a little angle going downwards from 0. So hopefully those two feel okay. Now let's talk about number 8. So if there aren't any degrees, then the value you were given is in radians. It just is. So this is -1 radians, okay? Well, that means we need to think about, well, this down here is -pi/2. Well, that means we're taking the number pi, 3.14, and we're cutting it in half. So it's got to be about 1.57, okay? 1.57, -1.57, is bigger than 1. So that means this angle is going to stay in the 4th quadrant here. And I probably should draw that a little bit more into the 4th quadrant. So -1, that would be about -1 radians, that turn for our angle. Now 2 radians, if I was going to try and graph that, that's going positively, so we know it's going to turn upwards. And let's use our same logic. This value up here at the top would be pi/2 or 1.5, positive 1.5. So our angle of 2 is going to have to go past 1.5. So we're going to draw it somewhere in that 2nd quadrant, okay? Not too far into it, but somewhere into that 2nd quadrant. All right, I'd like you guys to try the last 2. See if you can figure out where those would land. Pause the video and then come back to check your answers. All right, folks, so the last 2 we had to look at were 11 and 12. So if you look, -11/9 is going to be bigger than -1, so that's going to go just into that 2nd quadrant as it passes -pi. And then 12, this takes a little bit of approximating. So 3 pi would be like 9.42. So if we cut that in half, that's probably going to be bigger, maybe 4.7. So this -4.5 should be just a little bit before that vertical at -3 pi/2. Okay, last topic for today is arc length. All right, so you may have seen, so here's the form. First off, arc length is the length around the circle. So it's a fraction of the circle. I'm just going to draw you a little picture. Arc length is some length along the arc of a circle, all right? Based on a central angle. Okay, so it is this distance that I'm drawing in green, that would be S, your arc length, okay? The way you calculate that arc length is by taking the radius times theta, okay? Now, there was a time in your past life in geometry where you probably learned that S was equal to 2 pi r times theta over 360. And this was when your life was in degrees, okay? Your life was not as cool then as it is now. Let's just call it what it is. Because now you know that 360 degrees is the same thing as 2 pi. And if you know that, you can cancel those out. And that is how we get to this simpler equation for arc length. But there's a catch. This theta must be in radians. Fortunately for you, we are very often going to be working in radians, so this is going to be a lot more convenient. And then r, this is the radius length, all right? So theta, and here maybe we'll just make an additional note, that theta is, why did I write is, because equals is. So theta is the angle measure, all right? And I should probably also point out that this is the central angle measure, all right? Actually, all the angles you have been graphing where you're starting at the origin are technically all central angles, right? You're actually drawing like a piece that is a part of a bigger circle and its central angle anyway. So let's just talk through one problem real quick and then you'll be done for today. So suppose, let's look at number 2. Suppose I needed you to find that theta given the fact that S equals R times theta. So theta would equal S divided by R. If you knew the arc length, so like 10 miles, divided by 3, that 10 divided by 3 would be your theta value. Theta would be 10/3 radians. All right, because it is a measure, theta is a measure in radians. And then if you had to do a problem where you had to find S, especially a problem like number 5, you would just take the angle theta times by the radius 40, And I believe that one ends up getting us 30 pi centimeters.